Hello again, my name is Rene, and in this lecture we are analyzing in cookies, and I want to try to be as context as it could be for your project. So I make a few tutorials like in cookies how to use the main algorithms and tools, and you have to a little bit interpret it and use for your own project those steps. So today's main topic is vector analysis. I want to remember that vector is the one main data type in cookies. It shows a spatial relationships. Are two areas overlapping spatially? It could be outputting a difference between two areas, or outputting how much overlap are there on two areas. And also it includes analysis includes statistics, so how many points are in particular area, maybe it go on or join attributes by location. It's also important tool for us. But let's take step by step. This was overall understanding what we have to think about analysis in cookies. So in Teams, you should try to think last lecture and how 4 steps traffic forecasting model works. What are those steps? And now we are going to make spatial focus on half gravity model. So first step is to have input data, because we want to specify those areas where students start their trip, and then we want to extract the useful area, because like I said, we don't want to like make a non-motorized traffic road longer than, I don't know, 5 kilometers or 3 kilometers. We are taking care of one example, and when we go to the cookies, there are also some steps order to how to like solve a problem. First we have to state the problem, then we have to get the data, we have to analyze the problem and present the results. The present the results is mostly visualizing stuff. Analyze the problem is using algorithms and tools and the data. We have to have right data. For that we have to state the problem first. So example over here, I try to make this as context as your project needs. So the students who live inside schools buffer area, we want to like exclude only those areas where the school is not more than 3,000 meters away, and for that we have to go to the cookies. So I will open the cookies, and we will put first on the base map the OpenStreetMap. You know how to make it already, so do it. Like you see, I have opened the cookies already, and next I have to add OpenStreetMap as the base map, and let's zoom into the Pärnu city, and what I have to add now is all those 3 school data map, and for that let's navigate to our cookies data folder, and under the Pärnu folder you see Pärnu schools. It contains of 3 school positions, and let's visualize it a little better. Now we have to add also the layer of a statistic authority that shows us areas and number of students. We have this, I made a separate folder, so I have to navigate a little bit under the exercise. Few lectures back, I downloaded the males and females from the statistic authority, and we use this same data map as the input over here. I change the order a little bit to see it better. I also add labels, so I will single label and student's number, and I will make it graduated by student's number, and let's classify it, add more classes, and layer rendering. Let's take the rendering, let's little viewer. So what we have, sorry, we have all those areas, and we know how much students live on that particular area. We have 3 school positions, and now we have to use this off-gravity model to split, like there is a 40 students living on that area. We want to know how much students will potentially go to this school or that school. So we have to use on every area a half-gravity model. We are going to make it with help of the field calculator, and I will show you how to do it. So you have to, of course, use your context, your project data, but I only show you here how to make it so you can understand it better. But first we have to cut out some buffer area, because it's not very rational to start making a non-motorized traffic network from here, because it's too far away from the schools, and never students will use the bicycle or going to on foot to school over from this area. So for that, first I want to make a new project, of course, save as. I want to introduce you different algorithm tools. Under the vector, we see geoprocessing tools. There is a buffer. Yeah, we have to add a buffer, like I said before, and there is also always a description of this algorithm, and I suggest you to read it through. As the input layer should be Pärnu schools, because we want to make the buffer around the schools. Yeah? And we could also change the distance from 10 meters to 3000 meters, because it was our assignment. You see, I will show you that again. Students who live inside schools, buffer area, buffer 3000 meters from schools. So we want to make a buffer around the schools, 3000 meters distance, and we also have to check the solve result, because otherwise they are not there some overlap between those buffers, and we want to dissolve those buffers together. So dissolve results, and let's run and close. You see new buffered layer appeared, and we could use this layer to cut out all those areas that is covered with the buffer. So for that, so to cut out from the areas map, we have to use spatial algorithm. Under the vector, you see there is a clip, and the clip algorithm will output something that we want to clip out, but we have to use a template to cut it out. So our baseline or the input layer is of course the area map, but what we want to use the template as the buffered area, and let's see what it will result. And you see it will result something like this. Now we have cut out all those areas that was inside the buffer of 3 kilometers from the school. This is very rational because it's the distance that the students may be covered by bicycle or on foot. What we should do next, you see there is a little mark over here, and that means this is temporary scratch layer only. After I close the cookies, all the temporary layers will disappear. So I want to export it. So to export it, I just right click and export, save features as. Now I have to see that format is S3 save file, of course. The file name has to be something descriptive. So why not Pärnu clipped areas, and coordinate system should be Estonian coordinate system of 1997, and hit OK. Now new layer appeared. I will delete old layers. You see there is a remove layer group. Yes, I want to remove it. Buffer also, because I don't need it. I only need clipped areas. Let's visualize it again. You will understand it better than students. And so, and add labels also. Now we have only restricted area that we are going to focus on. Let's save the work. I suggest to save, or you make something new, then of course save it. And let's look, Pärnu schools should be something else because it's not very good visualizing at the moment. So next thing what we should do is to add street network layer, and it is also included to your cookies data folder, but I will explain it a little bit. First, when you remember from the 4-step mobility forecasting lecture, we want to know for the half gravity model a distance between every area to every school, and for that we have to add an street network data layer, and after that we could use the algorithm to compute out the shortest path. So let's open the data source manager, and you see I navigate to the cookies data folder, and under the Pärnu non-motorized roads there is a Estonian latest 3, and when you open it you see there is a GIS OSM roads 3. It is very important to add roads network layer, and just double click it, and you see new layer appears on the map, and the name is GISOSM roads 3.1. So this is the basic things to add to your project, so you can work on from here. Try to visualize it a little bit better maybe, and also save your project, and see you next lecture.